12, is there any questions that gave you guys trouble? I know there was one on the back that I just got alerted to that I messed up myself, so we'll talk about that. We'll talk about it. I definitely want to go over number 4. Is there anything else? 7, okay. If I walk around right now, we all got it done, Nom and Preet? 17, 18, perfect. And Ida? 20? Awesome. 10? Okay. A lot of the, oh, that's a good one, number 10. A lot of these that we picked out are fractions, so that's probably why they're a little confusing. So all we need to do here to find the value of k is to take each of our y values and put them over our x values. Do you remember what mnemonic we talked about yesterday to remember this? That's right, Roz. Y aren't you over your x? Not x over y. Y aren't you over your x? That's how we're going to remember this, right? Y over x. So we take our first y value, which is 5, and put it over its corresponding x value, which would be what? 10. Thank you, Darius. 10. There's our first point, 5 over 10. Now, we notice that our numerator is smaller than our denominator, right? So that means that our answer is going to be a fraction, but that's fine. How can we simplify 5 over 10? 2? There's going to be a 2, but is it going to be on the top or the bottom? On the bottom. 1 over 2.
But does it have to be up there?
What's that? Yes, it has to be a fraction because our, what's that? I got it. It has to be a fraction because our smaller number's on the top. Now, if we had 10 over 5, that would be 2, right? But if we even take a look at a calculator for a second and plug in, oh, you can't even see. If we plug in 5 divided by 10, we get 0.5, which is equal to 1/2, right? Let's try our next point, though. What's my y value for this next point? That's right, 4. And then what's the x value that goes with that y value? 8. Thank you very much. 4 over 8, again, we could simplify that. Thank you. So 1 over 2. So far, so good. We got 2 identical k factors. So we got to try for a third. The last one, we get k is equal to 3 over 6. If we simplified 3 over 6, we once again get 1 over 2. So all 3 of our k values are the same. That means that they are constant, right? We talked about the term constant yesterday, which means repeating the same over and over. So here k is equal to 1 over 2. Question? Great question. 0.5 is not technically wrong, but I always want you to keep your answer as a fraction. I'm not a fan of decimals, and you'll see why once we get to the later parts of this unit. Keeping it as a fraction will help you out a lot. Once we talk about slope, we're going to do rise over run, and we need 2 numbers in a fraction for that. So having it as a decimal just gives you an extra step of converting it into a fraction backwards. So keep it as a fraction. Great question. Roz? It would, so let's take a look at number 5 real quick. That's a great question. We again have smaller y values. So if we put y over x, that would give us 1 over 4. Can we simplify 1 over 4 at all? No, that's as simplified as we can. Now, yes, it is equal to 0.25, but like I said, we don't want any decimals. We just want to keep it as a fraction, 1 over 4. Yes, our k value for number 5 would be 1 over 4. We could check it out too with the others, 2 over 8, right? And we can even use what we talked about last unit with the power of a product if we need some help with simplifying, right? 2 is just 2 times 1. What 2 numbers multiply to give me 8?
4 and
2 times 4, good. Is there any factors that are identical we can cross out? Yep, a pair of 2's. And all we're left with is 1 over 4. We could do the same thing with 3 over 12.
So it's not every small number is
Say that one more time.
it's like so it's not every time it's not small number is above a big number.
That's right. It doesn't matter what size the numbers are. What matters is you're putting the y value over the x value. So in 4 and 5, our y values were smaller, which is why we have a fraction. But if we look at number 6, our y values are clearly larger. So when we do y over x, that becomes 15 over 5. Now let's break it up the same way we did here. What two numbers multiply to give you 15? Good morning, Hope. 3 times what? 3 times 5. Are we all still asleep? Maybe.
Yeah.
What two numbers multiply to give me 5? That's just 1 times 5, right? What can we cancel from the top and bottom here? The 5's. We're left with 3 over 1. But when we have a 1 on the bottom, do we need to write that 1 there? No, we don't. We can just call that 3. 3. 0.3, that would be if we had x over y. But we have to do y over x every time. So this one's just a solid 3. And once we take a look at graphs today, it'll most likely make more sense because we can physically see. But, you know, we'll get through it.
So when we turn 15,
15, yeah, we'll take a look at 15. Oh, that's another good one. Yep. So we got 2 more on the front to talk about, 7 and 10. Oh, I didn't give it you red pens. That's okay. No, it's all right. We're not going to worry about it. We have a lot less time today, and we got just as much to get through. So I want you guys to actually have time to get your worksheet done today. So number 7, thank you. Number 7, we put y over x. What's my first y value? What's my first y value, folks? 20. What's my first x value? 2. How many times would 2 go into 20? 10 times. Same thing with 30 over 3 and 40 over 4. Simplifies to 10. Simplifies to 10. Bless you. So when we have a larger number on top, we get a whole number. If we have a smaller number on top, we get a fraction. Then number 10, do we have a smaller number as our x value or our y value? Trick question, because they're the same, right? So if we're finding k, we could put 17 over 17. And what is 17 over 17 equal to? 1. Boom. Our k value is just going to be 1. 18 over 18 is also 1. 19 over 19 is once again just 1. Does that make sense for number 10?
number 8 is 0.125.
There should never be any decimals on this worksheet at all. So number 8, if we do y over x, 24 over 3 is equal to 8. It's okay if this is a little bit challenging at first. It's the first lesson of the unit. As we go through more and more, we keep adding on. It'll become more understandable, I promise. So if you're making some mistakes, totally okay. Homework is practice. Flipping over to 15. 15 is an ugly one. But if we do y over x, what's our first fraction going to look like? 10 over 100. Are we going to get a fraction here or a whole number for our answer? A fraction. Smaller numbers on top. So on the top we got 10 times 1. On the bottom we got 10 times 10. Anything we can cancel here? A pair of 10s go away. And all we're left with is 1 over 10. Don't even worry about what that would be as a decimal. Keep it as a fraction. Trust me. It'll help you a lot once we get to 3.2 if your number is a fraction. Real quick, just to go over here, 16. Our first value is 16 over 2. What would that be equal to? 8. There you go. Just like that. 3 more, 17, 18, 20. Now 17. I got one person out of, I mean maybe more, but one person brought it to my attention that this one is a little bit wonky. So let's see. Y over x, 144 over 12. What does that give us? 12. Good. 121 over 11. What does that give us? 11. What about 108 over 9? That's 12. So is our k value constant here? No, it is not. So this technically would be a non-proportional relationship. I didn't intend for that to happen. That was my bad. Good morning, sir. I should have put 132 in this box, but maybe I did it on purpose and so you could catch it. Whatever works for you. But if you caught that it wasn't all constant, that's awesome. And you have a better eye than I do. I'm not ashamed to admit. We'll talk more about what non-proportional relationships look like again as we go later into this unit. For right now, we're just dealing with proportional. So number 18, we got another weird one. We got tiny y values. So if we put, thank you, sir. If we put y over x, what's our first fraction going to look like? 1 over 7. Can we simplify that at all? No. That's going to be our k value, but let's check. Because now that we know that Mr. Church is making mistakes over here, we definitely need to check them all. If we do 2 over 14, right, what would that simplify to? If we have 2 times 1 over 2 times 7, cross out the 2's and we get 1 over 7. And 3 over 21 gives us 1 over 7 as well. So this one is proportional. We do have a constant of proportionality, which is 1 over 7. Totally fine if it's a fraction. And last but not least, down to 20. Now 20 is a really tricky one. So if you got this, great. What's my first ratio or fraction going to look like? 4 over 6. Y over x. Now this one we can simplify, but it's going to simplify a little different than all the other fractions on here. What two numbers multiply to give me 4? 2 times what? 2. And what two numbers multiply to give me 6? 2 times 3, or 3 times 2. Perfect. What can we cancel from the top and bottom now? We can cancel the 2's, and we're left with 2 over 3. 2 over 3. If we do the same thing with the next point, 8 over 12. Well, 8 is 4 times 2. 12 is 4 times 3. We can cancel out the 4's, and we get 2 over 3. I ran out of space, but if you do the third point on here, 16 over 24, you get the same exact thing. 2 times 8 over 3 times 8, yep. We get 2 over 3 that way as well. Just for fun, number 19, what would our k value be there?
5.
Over 5, which equals?
Oh, wait. No, 1.
1. There you go. And I heard it over here. Thank you very much. K is equal to 1 for that number 19. You guys okay? Okay, perfect. All right, final questions I can answer before we pass this one forward? Yes? 14 would be 1/3. That's right. 3 over 9. We got 3 times 1 over 3 times 3. Cross out the 3's. And we're left with 1/3. But what would 13 be? Would that also be 1/3? No, what would it be here if we have 9 over 3? 3. So there's a good little comparison for you of when we're going to have a fraction versus when we're going to have a whole number. These are the same numbers here, but the x and the y's are flipped. So you see that 3 over 1 flips into 1 over 3, right? Perfect. If you need more time on this, do not turn it in right now. Okay, you're not going to get points taken off.